Hey everyone, we're going to look at solving linear equations. So this is a topic that's in Algebra 1 and something you start in middle school. And the basic idea here is just trying to find a value for x that would work and make the equation true. So there's 4 examples we're going to look at. Some are basic and some get a little more complicated. And then we're also going to talk about some special cases of equations. Some that don't have an answer and some that have answers for every number. So, kind of getting right into it. A is pretty easy. We're using the additive property of equality. We're going to subtract 5 on each side. And the reason I'm subtracting 5 is because, well, 5 is a number without a variable and 26 is a number, so I'm trying to eliminate one of those. So I end up with 3x equals 21. And then I could use the multiplicative property of equality and divide by 3, as long as I do it by both sides, then I get x is 7. Now, I can always check these by plugging in 7 where the x is, and I'm just trying to see if we get 26 on each side. So I could take the calculator. I'm not going to do this with every question, but you should, as you are solving them, getting more comfortable with them. So if I type in 3 parentheses 7 plus 5, I get that 26. So this one does check. So for that first example, fairly basic. With B, we have more than 3 terms. We have 2 on each side. So now we're going to use that additive property twice. And it doesn't really matter which one you start with. I could start with any of the 4. I'm going to start with the 4x, and I'm going to get rid of it by subtracting 4x. And I'm just going to make sure I subtract it by the other term with the x. So I end up with 4x minus 7 equals negative 5. And then to balance it, because I got 2 on one side now, I'm going to balance it by adding the 7 on both sides. And just be careful, because when you do this, the negative 5 plus 7, when you type it in your calculator, it should look exactly like that says, which in this case would be negative 5 plus 7, which is positive 2. And then again, we're dividing by what's next to x. So you divide by 4. And you're going to get a decimal for this, which would be 0.5. But you could also change it back to a fraction using the math function. So if I have 0.5, and I do math and enter, I get that fraction out of this example. So now for C, we have a fraction, and it's always important, if you want to get rid of the fractions, you can. You could set a proportion for this and cross multiply. But when it comes down to it, to get rid of a divided by 2, you would have to multiply everything by 2. So it's kind of like we're distributing. So we do 2 times the fraction and then 2 times negative 6. So we'd end up with x plus 8 equals 2 times negative 6, which is negative 12. Then I can subtract 8 on both sides to get the x by itself and balance it out. So I'd have negative 12 minus 8, which would be negative 20. And again, you'd put it in the calculator like that. How you say it is how you type it. D uses parentheses. So we're going to be distributing for D. I'm going to distribute the 6 to the x and the 4, and this negative 2 to the x and the negative 1. So I would advise you to make sure when you do the negatives, type it in the calculator, make sure it's correct. You get 6x plus 24, and you get negative 2x, and then negative 2 times negative 1 is positive 2. And then we have the right side that stays the same. Now you can combine like terms on the same side of the equal sign. So I could use the commutative property, the rearranging. I got these 2 right here I could put together, and then I got these 2 right here. So I end up with 4x, because it's 6 minus 2, plus 26 equals 2x plus 20. So at this point, I'm going to let you solve this one by yourself. But the answer you should get should be negative 3. So finish that one yourself and see if you get that negative 3. And at this point, you could pause the video to do that. Now, moving on. I'm on the back of this page, the front page that you're looking at. So we're going to talk about a couple different cases. One is called inconsistent, which just means you get no solution. And the other one is called an identity, which basically means any value of x will solve it. So we're going to see what these look like. And we're going to kind of skip some of the parts in it, so we're not going to do everything for this. So this one, they say, try to solve it, state whether it's an identity or inconsistent. So again, we're going to start off with some distributing to kind of get things going. So we got 6x minus 2x minus 8 equals 3x plus 6 plus x minus 5. Now I'm going to try to combine anything. So I can combine these two on this side, which would be 4x minus 8. And on this side, I have 3x and x, and 6 and negative 5. So we end up with 4x, because this is a 1, plus 1. Now here's where the kicker is. You got subtract 4x on each side, and then those both cancel out. So what you end up with is negative 8 equals 1. Now this obviously is false, so that would mean that this is going to be inconsistent. So there's no answer that you could plug in. No number you could put on each side that's going to give you an answer out that would make it true. Now opposite that, if you look at exercise 4, now they're telling you to test the values of 5 and 3. If you test those values, you're going to get the same answer on both sides. So you would just plug those in and check them. Now as far as solving goes, I'm just going to go ahead and use the space to solve it. So I got a 3x minus 9 plus 2 over here. And I got 2x minus 6 plus x minus 1 here. So I'm looking for terms to combine. I can combine these together. I got 3x. I can combine these together, which would be negative 7. And then on this side, I'm going to combine those two numbers together and get 3x minus 7. So you'll notice that I have the same exact thing on each side. And I can continue to solve this, go back and forth. But what's going to happen, because the expressions are the same, any number I put in is going to get the same answer out. So this is your example of an identity for an equation, because any number would work on each side. Even though they look initially different, they do end up being the same. So those are kind of the special cases. And as you get to the questions that we're talking about, let's go ahead to the next page. So I moved on to the homework page. And what I want you to work on this page is I want you to finish question 1. So you're going to work on question 1. There's just several examples that you're going to use to solve. And also work on 4 and 5, which you need the graphing calculator for, because they want you to do some graphs. So they want you to kind of relate how the equations relate to the types of solutions you'd expect to see. All right. So if you have any questions, please ask in class, and good luck.